In an imaginary atmosphere, the air exerts a small force F on any particle in the direction of the particle's motion. A particle of mass m projected upward takes time t1 in reaching the maximum height and t2 in return journey to the original point. So which option is correct? So in an imaginary atmosphere, air exerts a small force F on the particle in a direction of the particle's motion. Suppose this is the particle. So particle projected upward. So it moves from position A to position B. Particle travels in the upward direction and travels from position A to position B. Then returns from B to position A. So particle travels from position A to position B. So this is the upward motion, and then returns from B to A in the downward direction. So this is the particle at middle point during the upward motion. During the upward motion, so acceleration due to gravity is g. During the upward motion, acceleration due to gravity is g. So acceleration due to gravity is g, which is directed downward, and small force F on the particle in the direction of the motion. As the particle is moving in the upward direction, small force F on the particle in the direction of the particle's motion. So F is in the upward direction. So acceleration equals to what? So acceleration equals to force divided by mass. During the upward motion, so this force is directed upward. Acceleration due to gravity is in the downward direction. So net acceleration equals to how much? Net acceleration during the upward motion is g minus f divided by m. So that is the net acceleration during upward motion. And in the downward case, so when particle moves in the downward direction, acceleration due to gravity is g. Acceleration due to gravity is g, and this a equals to how much? A equals to f divided by m. So acceleration is f divided by m, g is in the downward direction. So a dash equals to how much? A dash equals to g plus f by m. So a equals to g plus f by m in the downward direction. In the upward direction, acceleration is g minus f by m. In the downward direction, acceleration is g plus f by m. We know that s equals to ut plus half at square. As s equals to ut plus half at square, so as u equals to 0, s equals to half at square. So t equals to how much? T equals to 2s by a root over. As t equals to root over of 2s by a, so we have to calculate the time during upward motion, and we have to calculate time during downward motion. In case of upward motion, time equals to 2s divided by g minus f by m. So that is the time during the upward motion. In case of downward motion, so t equals to how much? T equals to root over of 2s divided by g plus f divided by m. So that is the time during the downward motion. So as acceleration is minimum in case of upward, so time is maximum. As acceleration is minimum in case of downward motion, so acceleration is minimum in case of upward motion, so time taken is maximum. Time taken is maximum in case of upward motion. So time taken is maximum in case of upward motion is greater than time taken in case of downward motion. Time taken is maximum in case of upward motion in comparison to than in downward motion. So time taken for upward is t1 is greater than t2. So time taken t1 is greater than t2. So option B is correct. So in this case option B is correct.